Good morning to all you incredibly diligent students. My name is Joab Rockman, and here's another short video on how to perform chemical engineering calculations using a not-so-simple calculator. Today we're going to solve a thermodynamics problem on the calculator by using the direct substitution method, also known as the successive substitution method. First, let's define the problem. We're trying to find the specific molar volume, V, for a gas, in this case isopropanol, at a pressure of 10 bars and a temperature of 200 degrees Celsius. The equation we're going to use in order to solve this is the two-term virial expansion given by PV over RT equals 1 plus B over V plus C over V squared, where B and C are the virial equation coefficients relevant for a specific compound and temperature. Note that this equation is cubic in V. For this example, for isopropanol at 200 degrees Celsius, B equals minus 388 centimeter third per mole, and C equals minus 26,000 centimeter 6 per mole squared. The first step we do is to isolate the variable we want to solve by rearranging the equation into the form x equals g of x. In this case, I've isolated V from the left-hand side of the original equation. V equals RT over P times brackets 1 plus B over V plus C over V squared. And the right-hand side of the expression is what I refer to as g of V. So now I have a way to update the value of V via the expression g of V. The method works as follows. Isolate the variable you want to solve from the equation so that you have an expression of the form x equals g of x. For our example, we've got V equals g of V. Guess an initial value for your unknown variable, V. Set the initial value into the function g of x to obtain an updated and new value for x, and rerun these steps until the solution hopefully converges. For our example, a good initial guess for V would be to assume ideal gases, so that V equals RT over P equals 83.14 bar centimeter third per mole Kelvin times 473.15 Kelvin divided by 10 bars. This equals 3,934 centimeter third per mole. Note the units of R are chosen to correspond with the units provided by the virial coefficients and the pressure, and note that the temperature has been converted to Kelvin. Now set up the problem to solve with your calculator. We're going to use the A&S answer button function in the calculator. A&S holds the last calculated value performed by the calculator. Simply type the initial value of 3,934 for V, then press the equals button to have A&S equals 3,934. So that's what I'm going to do now. Now type the expression for g of V and put the answer value A&S wherever V, our unknown variable, appears, including any mathematical operations performed on V. So we have 83.14 times 473.15 divided by 10 multiplied by brackets 1 minus 388 divided by answer minus 26,000 divided by answer squared, close brackets. Pressing the equals button will yield a new value for answer, in this case a new value for V. Now press repeatedly the equals button so that each time A&S is updated according to the expression given by g of V. After pressing the equals button a few, actually more than 7 times, the value of A&S converges to a value of 3,487.74. And this is our final solution for V. See me next time to see how I use this technique to perform successive substitution for a number of expressions that are linked to one another. I hope you enjoyed this video. This is Yoav Rockman saying to all you diligent students,